So the next section we're going to cover is going to be the start of systems of equations. And systems of equations, system means more than one. Equation in this case means line. So we're going to be finding where lines intersect. And for the next 3 sections, we're going to be doing this same strategy over and over, except we're going to be learning different methods in order to find the same answer. So what is a solution to a system of equations? Well, the first and most important thing here is systems of equations means more than one equation. And we know that equation, for the most part, means line. So we're going to be working with more than one line. Most of the time, it's going to be 2 lines, but not always. There actually could be problems where we're working with 3 lines, and we have to find out the solution. And the solution is where those lines intersect. And intersect means cross. So we want to find repeatedly in the next few sections where lines cross. And what we have here is we have 2 lines. The first line in red is 2x plus 2y equals 6. And I'm going to write that over here. And the next line over here is 4x minus 6y equals 12. And what I've done is I've given you the graph. So we're skipping the first step. And we found the point of intersection is the point 3, 0, which means this is the solution to this system of equations, where the lines intersect. And it asks us, find and check the solution to this system. So what I'm going to do is I'm going to take this point and I'm going to insert it into both equations, and I want to make sure that I get a true statement from both equations. So we know that an ordered pair is alphabetical. X comes before y. So I'm going to take this ordered pair and I'm going to plug it into this equation first. Well, if my x is 3, I'm going to do 2 times 3 for x plus 2 times 0 for y, and that should equal 6. Well, 2 times 3 is 6. 2 times 0 is 0. And 6 plus 0 is 6. That is a true statement. So we're half done. If our equation worked, though, when I plug this ordered pair into this equation, I should also get a true statement. 4 times 3 minus 6 times 0, this being x, this being y, equals 12. Well, 4 times 3 is 12, and 6 times 0 is 0, and that does equal 12. And that means that not only is this the correct solution, so we found the answer, down here we proved that it worked for both, so we were able to check our answer. So we found the answer and we checked our answer. Therefore, we're done. So now let's go back and look at the graph that we had right at the beginning of this video. And it says create a system of equations from the graph and then check their solution algebraically. So let's look at the blue line first. We know that every equation, when we're writing in lines, can be written in the form y equals mx plus b, and I'm hoping that the song popped into your head. So for this one, we know that this right here is our b value of 2, and from this point to this point, we go up 1 and over 2. So the blue line is y equals 1/2 x, because it's rise over run, plus 2. So the blue line, 1/2 x plus 2. Now the red line, our b value is right here, which is -3. And there's another point there. And from these 2 points, we're going to go down 2 and over 1. So the red line is y equals negative 2x, or negative 2 over 1x, minus 3. Because 1, 2, 3. So now we have created the system of equations, and now we have to find the solution to this system. Well, once again, the graph is given to us, so that means our solution to this equation is the ordered pair negative 2 comma positive 1. That's where these two lines intersect. Therefore, now we have to check their solution algebraically. And algebraically simply means by using algebra, which means plugging the values into the equation and proving that they're both true. So once again, negative 2 is x and positive 1 is y. Therefore, we're going to plug it into this equation and make sure it gives us a true statement. So if my 1 is my y value and my x is negative 2, I get this equation. Well, 1/2 of negative 2 is negative 1. Negative 1 plus 2 is positive 1. So this side of the equation is true. So now let's check the opposite side. Well, we're going to plug in both values here again. So we get 1 for y equals negative 2 times negative 2 minus 3. Negative 2 times negative 2 is positive 4. Positive 4 minus 3 is 1. So we have a true statement. So we did 3 steps to this equation. We found what the equations were, first part. We found the point of intersection, or the solution, part 2. And then part 3, we checked our solution algebraically to make sure it worked. So we have done all 3 parts to this equation. And everything we do past is going to just be working with a specific part of one of these 3. For this problem, we have 2 equations, and we want to find the solution and check the solution. So now that we're given the equations, let's look at this equation first. We have to graph it. Well, the graphing shortcut we learned in the last unit is y equals mx plus b. So for this equation, our m is 2 over 1, or 2, and our b is 3, or 0, comma 3. So let's graph that. 1, 2, 3 for our b, and we go up 2 and over 1 repeatedly. And we can go back 2 and down 1, just like that, and then we can graph using a line. There we go. And we can put some arrows on. So we have our first line done. Let's look at our second one. Y equals negative x minus 6. For this, our m is negative 1, or negative 1 over 1 for our x, and our b is negative 6, or the ordered pair 0, comma, negative 6. So I'm going to go down here and graph. And I want to go down 1 and over 1 right there. But I can't go down 1 and over 1 anymore. So let's go up 1 and back repeatedly. And I think we just found our point of intersection. That was pretty lucky. And right there. So we have now graphed both lines. And now we need to find out, where do they intersect? So I see it right there at negative 3, comma, negative 3. So point of intersection is negative 3, comma, negative 3. And now we just have to check it by plugging it back into each equation. So this equation over here, let's go negative 3 equals 2 times negative 3 plus 3. 2 times negative 3 is negative 6. And negative 6 plus 3 is equal to negative 3. So this is a true statement. And the problem on the right, let's do the same thing. So y is negative 3 equals negative 3 is positive 3. and positive 3 minus 6 is negative 3. So not only did we get the right answer, we know it's the right answer because we were able to check it.